Hey, so welcome to the EF Community Stand-Up. I'm Arthur. I'm the engineering manager on any framework. We don't have Jeremy, our PM and normal producer for this show right now, so I'm going to try and wing it on my own, and we'll see how it goes. So if things don't look as smooth as normal, that's why. Before we go, before we get started, let's have an introduction to the people we have here. Regular member of the team, Bryce Lamson's here. Bryce, you want to introduce yourself?
Howdy, I'm Bryce. Been on the team for 10 years as a developer, and I worked on the spatial feature during EF Core 2.2. So.
And we have Joe here, who is one of the developers on NetTopologySuite, who is going to show us about everything spatial today. Joe, you want to introduce yourself a bit?
Hi, my name is Joe Amenta. I've been a developer for about 10 years now, and most of that time has been working with either JTS or NTS, and so kind of one of the people to talk about this. So thank you for having me. One thing to point out, I work for a company called Urban Science, and nothing on this stream has anything to do with urban science. So just for legal reasons, I should probably say that.
Okay, fair enough. Okay, so we may have other people from the team drop in as we go, but they can introduce themselves when they do. I'm going to just share some links now. So let me do this right. See, did that work? I can't tell. Yes. Okay. So people can see these links now. I really should have another monitor set up here. Okay. So we have a few links today. I'm going to go through them quickly because I want to give Joe as much time as possible. The first one is something from our very own Jeremy, where he shows how to build link queries and then use the expression tree to send them and execute them remotely. This is pretty cool. I'm not going to talk about it too much because I think it'd be better for Jeremy to talk about it when he's back on the show. But definitely have a look at that. That's some pretty exciting stuff there. Then we have a link to the stuff we're going to talk to today. So we have some links to the NetTopologySuite repo on GitHub. This is where all of their work is done. And we have a link here to documentation. So all the documentation for all of this stuff is there. So if you need to look up that, then it's in the URL links. And then NTS is inspired by, is that the right way to say it, Joe?
It's very much inspired by, in the sense that it's pretty much a direct port.
Right. So
line for line.
So I was inspired by the Java Technology Suite, JTS, and there's a link here for more information about that. And then I want to also call out that we've released Microsoft Data SQLite. We released that at the same time as EF Core, but it usually doesn't get much press because we talk about EF Core. So Bryce has written a good blog here that shows a bunch of the changes that we've done in SQLite for 5.0. Do you want to talk about that briefly, Bryce?
Yeah, I want to give a huge thanks to the contributors. I mean, I think they're the only people that added features this release. I wrote a bunch of documentation, and then they sort of optimized these get bytes and get characters to stream more, so it uses less memory. And then, yeah, just a bug fix around the explain statement, and then add support for deferred transactions, which can give you more concurrency to the database. And then, of course, our dependencies updated. Eric Sink manages the SQLite PCL raw. He did some goodness there. He had a contribution. Again, community's huge contributors here. He had a contribution to enable MIPS 64 Linux architecture. And then, of course, another cascade as we updated the SQLite version that we ship with in the box. And it had some goodness around generated columns, which lights up in Entity Framework Core, and then some other goodness.
Good stuff. So I put the link up on the screen so you can go and check out any of those things. And I think now we'll just pass it over to Joe and have him share what he has to share with us. And let me know if you have a screen that you want me to share too.
I have a screen up there. Is it?
Okay. Yes. Is that it?
There we go.
Okay.
It's the
Whoa.
tunnel. Okay, so what I have for you today is a demo. Well, what I have for you first is a demo that's going to take some of my existing model here, and then it's going to sort of add spatial features and add this kind of thing as we go along. And so before I start talking about spatial, I'm just going to do a brief overview of what kind of data I have and what it really means. So here's my DB context, and what I have is a
Can you
bunch
bump
of
the font up a little bit, Joe?
Sure. I think
Control mouse wheel, I think is. There we go.
better. All right. So what I have are I should probably still make this a bit bigger. What I have are a bunch of parks and a bunch of cafes. And what I've done is I've grabbed these from OpenStreetMap by extracting from a specific key. And so when you have parks and cafes, sometimes you have parks that have cafes inside of them. And so with a traditional kind of relationship, I'm using SQL Server for Linux and some stuff to make it so I don't have to pluralize table names and so I can access data as JSON. But the long story short, we have a traditional relationship of here's for every park, we have a bunch of cafes that are in it. And for every cafe, it has 1 or 0 containing park. Everything else is pretty straightforward. We have the cafe ID. I don't generate a key for it because the IDs, I'm using OpenStreetMap's IDs. And then we just have a bunch of completely unstructured data from OpenStreetMap, just whatever the contributor happened to give us. And so I'm using .NET 5 the first release candidate, excuse me.
Nice.
And then as we go on, we're going to be adding some NetTopologySuite NTS stuff to it. My first query is going to show for each cafe that has a containing park, select just that cafe, and there's a navigation property to the park. And I have a database that I'm going to set up right now. And so the first thing I'm going to do is add a migration because I literally don't have it set up. So initial create. And this is going to set up my database from this model that we just went through. So .NET EF database update.
I'm very impressed by your EF skills here.
I definitely had some practice leading into this. Okay, cool. So I'm going to go ahead and just show that this database now exists on my local machine. We have the cafe. It has the containing park. There, that's all pretty good.
So for people who may be coming to some of the spatial new, can we look quickly at the columns and show that they've been created with in this case, database specific spatial types?
So far, we don't even have any spatial types.
Oh, we don't have any spatial. Okay, I'm jumping ahead too far.
So what I'm going to show
keep
is
going and ignore me.
So what we have so far is just a simple relation of for each cafe we have 1 or 0 parks that contain it, and this wonderful containing park ID column. And so when I go ahead and I'm going to actually load this data, I don't have any migrations for data loading. I just have this fun little thing where once if true, then I will go ahead and load.
That sure doesn't look like Windows, Joe. How are you running SQL Server?
SQL Server 2019 does have support for Linux.
That's awesome. And you have that. What was that? Is that the SQL? Oh, I forget the name of that tool.
This is Azure Data Studio. It's sort of a cross-platform-ish version of SQL Server Management Studio.
It's a lot like VS Code, only it lets you access the database.
Yes.
And everything. That's really cool. It's all running natively on Linux.
Yeah.
Yeah, I should try that. I haven't. I tried the tool there when it first came out, but it looks like it's got some better functionality now. So it's pretty cool.
Yeah, it's a real tool now.
Yeah.
I still prefer SQL Server Management Studio on Windows, but I have a Linux machine at home, and so I figured, what the heck?
Yep.
So the first thing that I've got is I should also point out that in my model, I do have it set to we're going to log everything that this does to the console so that you can see the SQL that EF runs. Okay. And so when we make the initial data load, which I've just commented this to if true, which I'm going to say if false now for future loads or future runs. We now have a bunch of things in our, I should probably take this drop database thing out so I don't accidentally run that. Select count one from cafe, select count one from park. So just to show, we have 767 cafes and 4,956 parks. These are just the cafes and parks in Michigan, which is my home state. So when I run this query, we see that there are, let me just run it and let it speak for itself. We have a few cafes that are in parks. This cafe with all of its tags is in this park. This cafe is in this park. And then this, I think there's about, this park actually is 3 cafes.
Wow.
So I think there are 4 parks that have cafes inside of them. And now we come to the problem with these kinds of traditional relationships. I had to say for every park, for every cafe, is there a park inside that it's within? If so, then I have to put then I have to say that this cafe is in this park, this cafe is in that park. That is very, very tedious, and it doesn't scale. What if I had football fields? What if I had little shops? What if I had golf courses? All these things create an explosion of relationships. This kind of model is just not going to work. At best, you'd have a massive table of relationships between every pairwise piece of data. So enter spatial data. And to enter spatial data, we have to put online a reference to NetTopologySuite for SQL Server, because every single provider has its own way of dealing with spatial data.
Yes. So maybe we should talk about that a little bit, because I think it's relevant to how Spatial and EF Core interact, like you're showing here. So for example, if you go back to EF6, we had spatial support in EF6, but it was very tied to the specific SQL Server implementation of spatial. So when we were doing EF Core, we wouldn't want to do that. We wanted to have something that could be used cross-platform and cross-databases. So not tied to Windows, not tied to SQL Server. And that's yes, the SQL Geography class. That's the SQL Server basically specific type reflected into a Windows only .NET type. And so we didn't want to use that, and that's basically why Bryce, I think, did a lot of research, and also Shai had done similar research, and we came to the conclusion that NTS, NetTopologySuite, was a great way to represent data. So given that, what we tried to do with EF is really nothing more than connect the server specific data SQL spatial support with the cross-platform, .NET Core NTS support for spatial, so that you could use those 2 things together and get spatial from databases and use them in NTS, and get spatial data represented in NTS and save them to databases and do all that query. So that's why each provider has like a separate package, because it's like specific to tie NTS into that package. But in reality, most of the work you actually do with spatial will be the same across providers, because you're just dealing with NTS and EF. So it's a pretty nice model. Postgres has support, SQL Server has support. Lawrence on the Pomelo MySQL, who I see is in the comments here, he added support for MySQL in the Pomelo provider recently. It seems to be working well. I think, Bryce, you may know there's probably other less known providers have it too. SQLite, of course.
Yeah, there's Teradata, which I haven't heard a whole lot about, but they have implemented spatial for EF Core. And then Oracle and IBM's DB2 and Informix both support spatial. I'm not sure where they're at adding entity framework implementations on top of that.
So let's go back over to Joe, but just wanted to kind of tie those things together for people.
Sure. No, that's a really big call out, because I mean, NTS works on any platform that supports .NET Standard 2.0. So your .NET Framework I would say 4.7.2 or higher. Your Mono, I think, and UWP. Every platform can do this. You see, I'm running Linux, so even if I didn't have SQL Server running natively on Linux, I could still connect to a SQL Server database through my through Linux to any SQL Server database and use the same code everywhere.
Pretty awesome.
The only things you have to worry about are the very few provider-specific things, and I go through one of them later in this demo.
Cool.
So I've turned on NetTopologySuite's SQL Server Integration. I'm referencing NetTopologySuite directly just to show you the package reference line for this. And then there's a GeoJSON. I use this just for data loading because I need to actually add the data to my tables, and I don't have a fancy migration for that. So how am I going to add this to my model? So first, I'm using SQL Server, and when I tell it to use SQL Server, it doesn't know natively that it has to use NetTopology, how to map with NetTopologySuite. So I go SQL Server in my onConfiguring method, SQL Server options, and just straight up use NetTopologySuite. I should probably have done a restore so that we can actually see the IntelliSense. In theory, live demo time. I did not save this, so my restore did absolutely, there it is, okay. All right, so we should be in the clear. So use NetTopologySuite and we can go to the decompilation and find, here's this fancy extension, and we can really dig into the whole thing about how that got implemented as something that's separate from SQL Server Core, but an extension that lets it still talk with NTS. Okay, so now that we're using NetTopologySuite, just because it's available doesn't mean we're using anything for it. So first thing to do is let's get rid of this not scalable cafes property. Let's get rid of this containing park property. So what we do is, let's say geometry, using NetTopologySuite.geometries, park geography. I'll get to that in a bit. So in order to add just a geography that describes the area that each cafe or each park takes up in the world, we need to have a NetTopologySuite geometry type. And this is one of the weird things about integrating NTS with spatial data, is that geometry in NTS is actually planar, just a bunch of XY coordinates, like we've all learned in high school, where on point X is 0, 0, point Y is 1, 1. The distance is, square root 1, 1 it's 1. Wow, okay. So we've, what we're doing is we're mapping this to a geography column, which we'll see when I do a migration for this. It's probably easier if I just make this, and then since we're querying by the containing park, that's not going to work anymore. So let's just comment that out. And I'll go ahead and build this to make sure it still works, and then I will make a migration to show you exactly how we're changing our database for this. So .NET EF migrations add change to spatial. Okay, this may result in the loss of data, and we kind of hope it results in the loss of data because that was not scalable data. So how does this migration change it? Well, first we drop all the stuff that's related to the containing park. Of course, it's just from cafe to park, so there's nothing to change on the park side. And then we add a column that is of type geometry. It is nullable because I don't have any data right now, so I want it to be nullable. It is of type geography. And so on SQL Server, which I might as well pull it up, spatial data overview, I think that's what it's called. There are two different types of spatial objects in SQL Server. There's geometry, which is what actually NetTopologySuite is using when you run it locally. But then there's geography, which is more familiar to us. Not so much familiar as but useful. Like, hey, on 3rd and 5th Street, there's this thing that exists. The geography type is something that represents the stuff that's on the Earth. And so when we map to a geography, we're saying that this park is something that exists out in the world, and this cafe is something that exists out in the world, even though we query it using geometry.
We talked a lot about whether or not we should add geometry and geography top level types. I don't know, Bryce, do you want to mention like why we ultimately didn't end up doing that?
Yeah, I think SQL Server is kind of the only weird one that breaks them into two distinct types. I mean, under the covers, they're identical, right? Like they both have like a vertical coordinate and a horizontal coordinate, and all the same method. You can still compute the distance between 2 points. And so I think the standard that all these things are based off is really defining geography or geometry. I get confused all the time. Is really defining a geometry, and it is really weird on SQL Server that you kind of have to know that this CLR type can represent both, because at the end of the day, it's just a data structure, and the data structure is identical either way, and the operations you can perform on them are identical mostly.
I think geography is a subset of geometry, if I recall.
Yeah, they do implement less on SQL Server. Some of the operations aren't supported on geography columns because the math gets too hard.
So it kind of boils down to we could have had geometry and geography types, which would have initially maybe made things look simpler, but I think ultimately it would have been more confusing, and it's better to just get this out of the way with to begin with and just understand that, and then it makes a much more consistent experience.
Yeah, and we one of the things we really wanted with this implementation was consistency across database providers. So yes, it would make a lot of sense for SQL Server, but when you go to Postgres, where there's not really a distinction, or you go to SQLite, I feel like, and this is one of the mistakes I think we made in EF6, is we made it very SQL Server specific, so that when Oracle tried to come in and implement it, like half of it didn't work because it didn't really make sense on Oracle's implementation. So
that's where we are now. We have geography, we have geometry. By default, because we think it's the most, or I guess everybody thinks it's the most useful, we map to a geography. If you want to change that, you can. I don't remember the exact attribute, but there's an attribute you can put on this that says, oh, please map me to geometry instead of geography.
Yeah, it's a column data type equals geometry.
Yeah. So I've got this, I've got my migration. It'll delete this unscalable column. It'll create these new scalable. I say scalable as in like if I had more data types, we wouldn't need to add more columns to this. So I'm going to go ahead and update my database, .NET EF database update.
That's an interesting idea that like you don't have to model relationships with spatial. You model like the state of something, and then you can derive all these relationships from them. I really like that use case for geometry.
Exactly. And so it's like you let the data tell you how it's related rather than you telling the data how their relationships are set up. So now that I've got this up, I have on my database, I'm going to go ahead and refresh this. I've actually got my provider specific geography type, cafe geography. Right now it's nullable, and in fact, always null because my migration wasn't smart enough to infer where each cafe was.
Is there any way to make the text on that window bigger?
Ooh, let's see if I can make this bigger. I think it's the same. There we go.
Cool, thanks.
Of course, now I have to make my window bigger. So we've got our geography provider specific on cafe, geography provider specific on park, and then of course our big bundle of JSON data. And just to show you what kind of data this looks like, ooh, wow, that is really, I am not used to this. Sorry, guys. We've got a bunch of completely ad hoc, not completely ad hoc. There's some structure to it sometimes. Like you can see that, you probably can't see, but this has the leisure tag set to park, and that's how you tell in OpenStreetMap whether something is a park or not. And this is called the Sturgeon Bar. This park happens to be owned by the United States, which is cool because I live there. So in order to load our data, to actually get the geographic stuff in, I hope this works. I've had some problems making this. Yeah, this looks good. So I'm going to go ahead and run this. It's going to load all of my parks and cafes data. I'm running this in debug mode because I apparently don't care about everybody's time. There we go.
We like to see the details.
Yes.
Cool.
And so there it is. It should all be there. We should see a bunch of 0xe6 or something. Yeah, there it is. So now this is sort of a blob. And this is one thing that I have to call out SQL Server Management Studio for. It has a much better way to visualize these park geographies. I don't know if you can tell where this is by the binary data.
I can probably guess why that is, because when you're running on Windows, you can use a SQL geography, and when you're running on Linux, you can't.
Yeah, that's probably it.
Yeah, this is actually that. So that data format, and I'm totally triggered by that. So when we wanted to sort of add spatial to .NET Core, we were blocked on the SQL Server team for the same reason as everyone else. These SQL geometry and SQL geography .NET types weren't available on .NET Core. And so we had to think really hard about how are we going to bring this to .NET Core, and which is why it took us so long. I mean, there was a bug with 200 plus comments on it saying, why haven't you brought spatial yet? And this was one of the reasons. And so we started looking at ways to make this happen. And it turns out that Microsoft publishes a spec on the data structure of this binary thing. Yeah, I don't know if you'll be able to find that, but so it tells you like what all the bytes are and how they represent X, Y coordinates or longitude, latitude coordinates. And so we dug in and we actually implemented a serializer and a deserializer to go from that binary format, which is this little project here, this assembly NetTopologySuite.io.SQL Server bytes. And so it has that serialization, and it completely bypasses those traditional SQL geometry and SQL geography .NET types. And this is what the Java provider would have to do as well. They'd have to go through this binary format. So we actually, we contributed this to the NetTopologySuite project as part of our spatial work, and which was really cool because a few weeks later, maybe months later, the NHibernate people switched over to using it, which is awesome. That work being done by the Entity Framework team has started benefiting the NHibernate team and unblocked a bunch of other stuff outside of EF. So
that's awesome.
Community is great.
A little side note to that. That's if you turn on sensitive data logging and you see the values that we're sending to and from SQL Server for spatial stuff, you'll see that they're just binary blobs, and that's why that is as well, because we convert them to binary before sending them down the wire.
Yeah, this is I really like this kind of work, data formats, and then finding a way to like map that to something in a CLR type. I really love this stuff. Okay, so it seems like we've got our data loaded. Yep, there's the 0xe61 bunch of bytes. So now let's actually go ahead and change our model. Now that we've got everything loaded, I'm going to make this no longer nullable because I don't like having to deal with nulls, and I've got the nullable C#9 turned on, or
Nice.
C#8. So this is required, and this is required. So I've made a change to my model. I'm going to make a new migration to apply that change. Make spatial required. There we are. This time it doesn't result in the loss of data. We've got alter column. It was nullable. Now it's not. Okay.
Yeah, the idea there is if you had any nulls in there, they'd have to no longer be null. So that null data would be lost, which is, marginal. But
Yeah. So we're not nullable anymore. Once I apply the migration, EF database update. And
we had a question on the null stuff. The null exclamation point.
Oh.
What does that mean, basically?
So when I make my model, I do it very simply. I just sort of make a get set property. With C#8, it lets us figure out things like, hey, is something possibly going to be null when I dereference it? And when I have a property like this, the default would have been null. And so if I take this out, I'll show you what happens when I take it out. this is going to give me a warning on my park geography entity. It says, here's a non-nullable property. It's got to have something non-null when we're finished with the constructor.
So we probably don't want to go off demo script here because I wouldn't recommend that. But rather than doing that, one thing you could do is, because EF Core supports constructors, you could make that actually a read-only property and put a constructor in it that sets it, and that would also satisfy the nullability. Of course, that doesn't work if you really want it to be mutable, because although you could, I guess you could still use the getter and setter on there.
Yeah, that equals null exclamation point. That's called I forget what it's called, the null forcing
It's
operator.
the null forgiveness operator.
Yeah, so
it's
it's a good pattern
not what it
for
used to be called.
when your data is going to be loaded, like not by newing up a class, but like for instance by a framework like EF, like that property is never going to be null when we pull something back from the database because it's non-nullable in the database.
Yeah.
But the language doesn't know that that's going to happen. So this is just a way of saying, trust me, it's never going to be null, even though in theory you could initialize this and it would be null.
Yes. And so that essentially what that means is I'm promising that when if I were to new up an entity and then make an update to my data store, then if I forgot to set this, then it would fail at update time rather than at the time when I'm trying to use it. So the compiler is not helping me as much as it would otherwise, but for the demo purposes, we kind of know what we're doing, and it's not really a big feature of this demo.
Yeah, this is kind of emerging as a common pattern too, I think, for serialization type frameworks.
Yeah, I'm hoping that get init will help with that, but I guess we'll see. Okay, what I've done is I've said this was nullable and now it's not. So I believe did I just make that update? I think I can run this multiple times just in case I forgot.
You can. It'll just say there's nothing to be applied if you've already applied the migration.
Nothing applied. Cool, we're up to date. All right. So now that I've got this non-null thing, I've got all this infrastructure all put together. Now let's try rewriting our query so that instead of cafe.containing park, we can actually figure this out. What I would really like to do is I would like to put join park in ctx .parks on, and then here's where the problem comes. Because the built-in language query, the built-in link stuff, the support for inner joins is very limited. I think you can only do like an equals.
Yeah, I think link is very limited on that.
We'd need Smit to know for sure, but
so
I think we'll lift where clauses into the on clause. I'm not entirely sure though.
For now, all that I know how to do is to make a cross join and then do a filter on it, which I think SQL Server knows just fine how to do that. So I'm saying for every cafe, for every park. So now I need to say where the cafe is in a park. So where cafe, or how about where park geography, just dot contains cafe, dot cafe geography.
So what exactly are the geography types that you're using there? Are they? It doesn't make sense if they're both points, right? Because like you say, well, so the park is defined as some boundary or some box, and we don't really need to know about that. We can just use it abstractly. Is that kind of what you're showing here?
Sure. The actual geometry types are, in fact, cafes has in my cafe data set, there's actually two types of geometry. Some are points, and then some are polygons that actually describe the exact outline of the building.
Oh, right.
It's up to whoever made the data on the OpenStreetMap project to determine whether they wanted to go through all the effort of saying, here's the outline of the cafe, or if they just want to say, here's the point where it roughly is. Parks, on the other hand, are always polygons, and so this polygon, I'll show you. Once I do this, I'll sort of show you what this data actually looks like on the source. So I'm going to go ahead and say, so since I'm doing this cross join, I no longer have a way to get to the park from the cafe. So I'm going to say new anonymous type cafe equals cafe. And actually, since I'm only looking at JSON data, let's kind of cheat and not pull more stuff down. Cafe JSON data. And then park JSON data, park.json data. So now I've got cafes and parks. So for each cafe and park, I don't need this anymore because I've got them in this anonymous type. So the cafe is cafe and park. Cafe JSON data. Cafe and park JSON data. So now I'm going to see for every park that contains a cafe, I'm going to include the cafe and that park. Let's actually add the ID so that I can do that thing I was talking about. I can just do cafe.cafe ID, park.park ID. And I'll say cafe number, cafe ID, park number, cafe and park.park ID. And so now I'm going to see, hopefully, those same parks that we saw before. I think there are 4 parks where one had 3 cafes. And then we'll see all that on this. And I'm going to, since there's only a few entries, I can actually show you the SQL that was actually generated here. So this is select the cafe ID, the park ID, cafe JSON data, and park JSON data. From the cafe, here's that cross join I was talking about. And then we have this where clause, where the park.st contains cafe geography equals this. This st contains is something that EF wrote for us, and it's mapped when you add NTS here. This use NetTopologySuite sort of lights up all of these things like contains, buffer, union, all of these spatial operations. It knows that when I type this .contains into my EF code, then it knows that this means st contains on the database side.
Yeah, the NTS extensions for Entity Framework are super lightweight. All they're saying is how to go from this NTS method call in a query to this SQL Server function call in the SQL. There's like no logic, really. It's just a mapping from function to function.
Yeah. So I can go over to my database and I can rerun that same query just to show you that there's no magic here. And it takes a little bit. There we are. Here's our cafe IDs, park IDs, and the cafe. These should be the same that I had before. In fact, that's actually how I generated those contains before. Those direct relationships. So we're writing out things like
question in the chat. Is there an intersect method that gives cafes that are partially inside a park?
Yes, there is, and it is as simple as .intersects the cafe. So this will be, whereas contains says if the cafe is fully contained within the park, then contains returns true. With intersects, it's if even the tiniest 1 point of the cafe happens to be park adjacent, it will return the entire cafe to you. And I could run this too.
Probably the same results, right?
I hope so.
Unless there's a cafe that's half inside a park.
Yes, that's kind of looks like the same exact results. We have st intersects instead of st contains. There's a bunch of other relation operators as well. So there's is within distance. So is this cafe within 500 meters of a park, for example?
So to answer another question in chat. So basically, yes, you can use all of these kind of spatial operations to understand the nature of how your spatial types, obviously on the surface of the Earth, like we talked about, intersect each other, which is super valuable and useful, and not easy to just replicate by writing. You know, if you try to roll this your own, you think, oh, I just use X and Y. But as we were explaining earlier, that's fine if it's Euclidean geometry and you can just do normal calculations. But you want to find out if this park intersects, if this cafe intersects this park and it's on a curve, you'll get it wrong if you're just trying to, hack it like that. So having this stuff built into the database is super, super useful and super powerful.
Now, having said that, you still need to know what your data is in order to get the performance that I think we would all want from our database. And I'm going to show a spatial index just to sort of give away what's coming up. But right now, I want to just show that when I said this cafe is inside of a park, I want to actually figure out what cafe that is. And so to go this, so I got the data from OpenStreetMap. It's a freely available data source for a bunch of geometric and geographic data. It has,
It's like Wikipedia for maps.
yes, that's a really great way to put it. And so this is a cafe. This is called Katie Inn. And so I looked it up by the ID that I put into the database. I happen to know that this cafe is a way. There's also things called nodes, which are just points. This person took the time to just sort of sketch the outline of this cafe. And so this cafe happens to be within whatever park this is, or sorry, it happens to intersect, which is, of course, in this case, contained within, I guess, Ford Park.
Yep.
I think the Bing Maps team actually contributed all the building outlines to OpenStreetMaps. I think I remember reading that.
That's pretty cool.
I did not know that.
There's so much more spatial there now than there used to be. I remember back in the early 2000s, no, before that, late 90s, I was doing high altitude ballooning in Iowa, and I wanted to, find a map that was free and I could use. It was not easy.
Yeah, there's been in the past couple of years, there was a big push for donations, and I think that was they met a big target with OpenStreetMap to still have coffee.
We have a quick interlude question. Okay. Is there a guinea pig in the background? I have failed to see one, but somebody seems to think that there is. Who has a guinea pig?
I have a parrot, and she is she's being very nice right now. She's letting me mostly talk.
Good. Okay.
All right. So we have this intersection of the park and cafe, but like I was saying, there's really not that much data here. I mean, 4 parks. What if you're going to plan like a cafe and park outing with like a group of friends? You're going to want to know more than just what cafes are in parks. I think we can walk a little bit more. So we can do things like let cafe to park distance equal park.parkGeography.distance to the cafe.cafe geography. And so I actually have a habit of always tagging my units. So this is the distance in meters. And how do I know that this is the distance in meters? Well, when I go here, I can select the park geography.st from park. This is going to tell me that the SRID, which is the spatial reference identifier, and don't worry if these are just jargon for now. I'll try to explain it a bit more. This essentially tells me when I have a latitude of whatever and a longitude of whatever else, what do those actually mean on the Earth? And without going into too much details, there's several different ways that you can interpret latitudes and longitudes. And this one happens to always use 4326, which I'm going to show what that means from sys.spatial reference systems, where spatial reference equals 4326. This is called WGS84, which is the most common model. GPS, the GPS system uses WGS84. This is sort of our best approximation that we know of right now for what the shape of the Earth is, which you of course need to do to figure out how do you get from point A to point B. What's the shortest path? What's the distance? And this particular 4326 happens to use meters for its measurement. That's sort of what I wanted to point out here.
With
we have
British
meters
spelling and all.
Yeah, I was noticed that.
Of course.
Yeah, so
this is distance.
Normally you don't have to worry about these things, like Joe said. But of course, this is also because while the Earth is not flat, and I'm fairly confident in asserting that, I'm also confident in asserting it's not spherical either. It's like a bulgy ellipsoid thingy. So that's what those are basically saying. Map it to some kind of bulgy thingy.
That's an excellent technical term.
Bulgy
much better
thingy,
than
yeah.
ellipsoid.
Yeah.
So I like to tag all my variables that have units with what the units are. So here's our distance in meters, and here's how many meters there are in a mile. So if I want to say where the park is actually, okay, where the distance, since I have that distance, is less than or equal to, let's say half a mile. So 0.5 times meters per mile. So now I can select all the cafes that are within half a mile of the park, of a park. And so then let's say cafe to park distance in miles equals meters divided by meters per mile. So now when I select this out, and I'll say like, what's the distance? So distance is cafe and park dot miles. And I don't need every decimal place known to man. So we have the distance in miles. So now when I select this, we're going to see two things. First, we're going to see a bunch of things streaming in. But actually, before that, we're going to see a big delay. There we go. There's a few cafes here and a few parks. And the reason why this is, and this is not going to finish during this meeting, so I'm going to talk about it and then I'm going to kill it. Is going for every cafe, for every park, find the best distance between them. And since like I was telling you, a cafe could be a polygon that shows the outline. It has to figure out, okay, is this the closest point to the polygon in the cafe to the park? Nope. Okay, what about this one? What about that one? And this is a really common thing you'd want to do. You want to know, give me all the cafes that are within half a mile from another park. I mean, that's just a very fundamental thing we need to be able to do. So I've killed it. We need an index. This is a classic thing for we don't have an index, we need an index. So how do we make an index? There is no, I don't know of any EF Core specific ways of doing a spatial index. I think I just need to do it raw SQL.
Yeah, you could do raw SQL inside a migration, but we don't currently have any like model building API to say add a spatial index. I think Postgres actually does because they're basically normal indexes, where on SQL Server they're not normal indexes.
And so I guess for the least common denominator, people using SQL Server, I'm going to just make an empty migration here. And I'm going to just say SQL create spatial index. I don't know if there's like a standard prefix. I just SIX name of park underscore name of park geography. That's the name on. Okay. On park. This is a fancy syntax. You can look it up. If you haven't just made this demo prep and done this a zillion times, and you probably would want to look it up on the documentation.
Absolutely.
But for the purposes of this demo, I'm just going to make these and sort of YOLO it in. And to go back down, we go ahead and just drop index. Consistent as always, you don't say spatial when it's going back down. Drop this index on that. Okay, and to reread it like 5 times to make sure that I didn't make a silly typo. Okay, this migration looks good. So now .NET EF database update. And so now I have a spatial index. And what a spatial index does is, well, it's kind of exactly what you think. It's a way to index your data so that for spatial queries that access, for any queries that access the spatial parts of it, we'll know, and I think it uses a grid for this, we'll know that any cafe, I guess we'll probably start from a park. For that park, any cafe that has any part of it within like a bounding box around the cafe. Did I say that right? It will know that this is like half a mile. It only needs to look at the things that occupy the grid tiles half a mile out. The upshot of that is I need to make sure that I created the spatial index, and I did. So I'm just going to run this, and it's going to probably finish by the time I finish this sentence. Darn.
Wow, that's a lot faster.
Yes.
So yeah, it doesn't stop you from this spatial, like zillions of dimensions possible with these spatial queries. That doesn't stop you from having to think about, ooh, do I need an index on this? What kinds of queries am I expecting on this? Will this scale? It doesn't stop you from having to think about regular index stuff. Should I put an index on this column or not? There we are.
Nice. So Lawrence, the MySQL, Pomelo MySQL says that they have a has index is spatial. So maybe we could look into if we can do that in SQL Server too.
Yeah, we have an issue with backlog. We could easily do it.
Yep.
For now, if you're a crazy person like me and you memorize these kinds of syntaxes, then it's not a blocker, but I would definitely like to have a more straightforward way to say that in my model.
Yeah.
So would we.
So that's my main demo about NTS with EF Core in general. Is there anything that someone wants to go over before I switch over to perhaps another side demo that I have sort of not too prepared?
I threw together some slides so we could talk about too. I don't know.
Well, we're at 10:50 now, so we can certainly keep going longer if people are interested. Let me just show one comment here, which was fairly large, but it's basically saying, if I've got a lot of data, is it still useful to use NetTopologySuite and put them in a database?
It entirely depends on the complexity of the data rather than the size. If you have something that has like a huge, long, stringy polygon, then that's going to occupy a ton of spatial tiles like all across. But it won't occupy a ton of those tiles, so the spatial indexes won't be as good. There's a lot to go into it. It's hard to say just 50 gigabytes, yeah, 100 gigabytes, no.
Yeah.
It's really a complexity thing rather than a size thing.
That makes sense. So what do we want to do next? Does anybody in the comments have any further questions or other things that you'd specifically like to see? That'd be great. Bryce, I don't know. Do you want to go over a couple of things you had, or should we do just? I assume, Joe, that you're okay with not doing your next demo.
Sure.
You've done the most. Yeah. Okay. So
go ahead if you want.
So let me add Bryce here. And there we go.
Sorry, one monitor as well.
Yeah.
Yeah, so I thought this just might be interesting for people to see. These are kind of the different spatial stacks on different technologies. Joe briefly mentioned JTS, which is the Java topology suite, which has existed since before .NET existed. I think it came around in like 2000. And all these things are sort of based on this OGC specification, which defines all these operations like distance and intersects, and there's a bunch of them. And so this was kind of the first programmatic interface on top of it, and Hibernate was built on top of that. Shortly after JTS came out, they ported it to C or C++, one of the two.
C++, yes.
Into this GEOS, primarily for the PostGIS project, which was the Postgres implementation of this OGC simple features specification. And then later Spatialite came and reused this GEOS thing to add spatial to SQLite. And then NTS is like GEOS is another port directly of JTS, only for .NET. And of course, NHibernate, which is a port of Hibernate, sort of parallel stacks here, built on top of that to implement spatial. And so when we were looking at different spatial libraries, when we were doing EF Core, NTS was really the best fit. There were other ones. There's ArcGIS, which is super powerful. Unfortunately, I don't think it implements the OGC simple features spec, so it didn't really map to what SQL Server and SQLite and Postgres and all these databases did. And then there was one for like OData had a system.spatial or something, but it was super narrow in its view. In fact, if we look, I have another slide here. This is kind of what parts of spatial, OData, and Cosmos DB happen to implement. OData really only implements 3 of the dozens of operations, like distance between things, whether 2 things intersect, and then like a length of a path. and Cosmos, again, have very limited support here.
We haven't added Cosmos for support for Spatial yet, right?
No, we haven't yet. But it does support this GeoJSON standard, I believe, and along with these operations here. So we could add limited support for that. These three methods at least would work.
Yeah.
From NTS.
Which gets you, even though it looks very limited and it is compared to the power that you're going to have, it's still useful to even just have those things, I think.
Absolutely, yeah. So like the two big spatial scenarios to me are like, I want to get coffee. Where's the nearest cafe, right? That's the distance. Find the thing with the shortest distance from where I am. The next big scenario, I think, is like the pizza delivery thing. Like I live here. Which of these pizza delivery places deliver to my house? Which delivery area am I within? So that's like 90% of spatial scenarios in my mind for apps. So I think it is really pretty good support, even though it is limited in what it can do.
A long time ago, I wrote a route calculation engine when I was working on satellite navigation systems. So that gets you from where is the closest one to my house by as a crow flies to actually, if I had to walk there, how long it is. But I don't think most people are going to implement that kind of thing in their application. It's fairly complex.
There is support for that in a library called Itinerary
really?
for .NET. It can use OpenStreetMap data, and it will extract the roads from that and say like, "Ooh, this is a walking path," and so you can, if you have a walking profile, you can go down it. It has.
Oh, cool.
I've actually contributed to that a little bit in the past. It's pretty cool.
Very nice. Yeah.
Here's a reiteration of all the databases that implement this OGC standard that we talked about. Of course, we have EF Core providers for all these now, and Teradata has one too. Still waiting for Oracle and DB2. And then another slide I really wanted to show is one of the things that really drew us to NTS was both how compliant it was with the standard. So it has like this as text and get geometry and stuff, but it also had these alternatives that were very idiomatic to .NET. And this is another problem I had with the EF6 implementation, is you couldn't do simple like indexers or dot length into things. And it felt very weird to call these methods here. So I really appreciated that about NTS, that it both had sort of the compliant definition of the methods, but also the more idiomatic C# thing to do.
Yeah, I really like that too. That was definitely a plus point for NTS there.
So before we call this wrap this up, I do want to shout out a couple of the other developers who were working on this project before I got on, Felix Obermeyer and Diego Guidi. They were working on this since before it was even on GitHub. It was originally on Google Code, and if you look through the SVN, they're all over the place. I just came in a few years ago as a contributor, although we've been using it at work for quite a while. And so I wanted to say that those guys are really responsible for the majority of what we see here in NTS. I'm just representing the team because I happen to be available.
That's awesome. Thanks, Joe. Yeah, and I think it's another example of how the open source community around .NET is really growing and getting very vibrant, and it's great to have these kinds of discussions where we've got Microsoft EF stuff and NTS stuff, and then it's also making Hibernate better at the same time. This is super exciting to have all of this open source work on .NET. And very, very happy for all the contributions you and everybody else have made. Yeah,
thanks for your guys' help. You made doing this spatial thing really awesome.
Yeah, it's been good.
It was great working with you guys during the development. It was definitely some interesting times for me. Definitely came out of nowhere where it's like, hey, let's actually add this to EF.
Yeah.
Okay, what does that entail?
Yeah. Okay, so we're out of time. I think it's been a really good discussion. Feel free if there's additional questions to follow up on our GitHub or a tweet or something, and we'll definitely try and answer more questions. But for now, I think we'll call this, and thanks again to Joe and everybody for watching.
Thanks for having me.
now I have to figure out how to stop the. Okay,
The
so
first
I'm supposed to do some kind of video, so which ends it, but I can't remember what the button is because I only learned this morning. So either no, it looks like John's off the stream. So I'm just going to say bye everyone and hit end broadcast, and hopefully that works. Bye everyone.
Uh,